time to do something. More videos for the god of videos. Look at these two. More lectures for the god of lecture. More videos for the god of videos. Yeah, got this. Here is okay. This can be switched off. This also no longer needed. This I can fix later. Okay. What do I have for today? I would like to speak about harmonics flow in power networks. What I got? My own personal power source. When everything will be in dark, I will catch somebody, possibly chain, to the radiator and get my own power. But that is one. Smooth probe. Scope. Here is my scope. Yeah, this is ground. This is what. Do you see the voltage? Should be sine, isn't it? Or cosine, or something harmonic. But this simple generator produces something a bit different. Not any generator produces nice sine or cosine. It's possible, it's a problem. Actually, where should we look? Generator. More generators. Focus on generators. For example, this one. what's wrong? Yes, it will need some repair. A couple of months ago. Okay, it produces a bit of energy. But why? Why we are looking on this generator? What's with it? Here is spare rotor for it. See, it's a form. If we have something like this, let's say coil, and it's rotating with the speed of omega. We have so-called state, and here one wire of the stationary winding. What will be voltage here induced? Minus number of turns and first derivative of the flux. Excitement of field current is constant, or here we have excited field from permanent magnets. So field strength is constant. What's look? We will what we will see? Rotation speed is constant. That means what? A induced EMF will be derivative of the flux distribution. For example, very popular design of power generator. For 50 Hz it will be RPM. Rotate with the speed omega. Has an excitement winding on poles. Here is the zero line, and I can draw relative to angle of. I can draw a field of it. Angle, induction. What will I see? 1, 2, 3, and here somewhere 4. Problem. See, this distance is smaller when from this point to this. And for this case, I will get something like this. It's induction as a function of angle alpha. There will be no sign. Output voltage will be derivative of this. So it will have, if not doing anything, this one is very similar. This tiny generator. Come on, tiny generator. See, voltage. You see what is produced instead of sine? Small funny generator. It's not sine. Do I have one to show? This one has a transparent bottom. You can see winding and rotor like barrel. Barrel like rotor. I'll show it to camera. For such barrels, it's very characteristic voltage like this with zero peak again, zero again peak for such barrel like rotor. So without some measures, such kind of generator will produce not sine but something. Here is small. This one is polyphase, three-phase. See how what's the design of rotor? You see this channels between poles are not straight but form a kind of spiral, like a barrel of gun. It's done to smoothen these parts. For large turbine, generator for turbine, it's a very common trick not to cut groove straight, but like a kind of spiral or really gun barrel. Also, winding can be shortened, but that's not another possible thing. It's heavy. I should take from machine laboratory. Another trick is to cut. Wait, this. Hey. If you disassemble generator from, let's say, ship's diesel or something like this, you can find that rotor has a cut in these areas filled with insulating material, something like micarta or G10. These cuts are made to make resistance of the side areas, magnetic resistance higher, and also lower these parts of induction curve. But at present moment we saw single phase generators, yeah? And what about polyphase, three phase? Why we are interested in three phase system? Any idea? machine. I disassembled smaller synchronous motor. Can I switch here? Don't do it at home. Hey. See what's going on? Why ball runs? Don't do it with your own motor, without current limiter. It will burn. Why it runs? You have a polyphase network. Can be drawn schematically as A, B, C. In time, A phase, B, and this is phase C. It's a voltage in time. ABC phase voltage in time. Use a system of coils. This one will be for A phase, for B, and for C. For time moment 0, let's say for this time moment, maximum voltage is at A phase, yeah? So, maximum of magnetic field will be here. Next moment, here, max voltage is B, maximum of magnetic field is here. Next moment, C, and so on. What we will see? Rotating magnetic field. Maximum of magnetic field goes forward and ball is attracted and in theory, not in theory. What I got in my head? Motor. How many phase? 2. It's a 2-phase motor. See? 1 second. But such kind of motor is not the best one. Why? Magnetic field is of elliptic shape, and elliptic shape field means vibration. It is easy to split single phase into example. So the single phase motor, but actually it's a 2-phase. Second phase is split with the help of capacitor. Yeah, here it is. And rotor it had. You see the chevron-like structure. It's to soften vibration. Most are with this kind of rotor on diagonal. This one, to stop vibration, had a double rotor with chevron-like structure. With the 3-phase, you will have no vibration because 3-phase system produces equal distribution. But that's not all. Key element is not with rotating field itself. Take a look, you will not see it on a Facebook. See? It's not an advertisement of Coca-Cola. Nothing in here. Why it rotates?
Can you change direction?
Easy.
Is DC motor?
AC, simple, asynchronous, rotates in opposite direction. Just change phase sequence. Easy. Why it rotates? Can Google answer? Why Coca-Cola? It's not a Coca-Cola advertisement. No product placement here. Why it rotates? Nothing, it's a simple disposed. Nothing in here, no magnets. See how it works. It's put in rotating magnetic fields. Yeah?
Because frequency change and pulse and change in the motor.
Yeah. Frequency, not change. Frequency is constant, 50 Hertz.
Yeah.
But magnetic field rotates around. When something conductive is in change, it stands. Field rotates around. When we have a frequency difference. Actually, it's 3000 RPM. When it rotates, it induces current. Any conductive object put in changeable or non-constant magnetic field, what is subject to induction? EMF is induced. When EMF is induced, current tries to flow. Can current flow? Yes, we have a closed circuit. All this surface is conductive. When current flows, magnetic field arises. Yeah? It's unparalleled. And magnetic field from induced current comes in mutual operation with the rotating field of the coils, stator coils. That means what we will see? Moment, mechanical torque. And mechanical torque rotates. Get a good conductive cage. If you open electrotechnic book, they will show you this Rex cage or squirrel, better use squirrel cage. System of wires forming a set of closed contacts. Current will flow in these wires, magnetic field will emerge, and moment, torque, good word is torque. Very simple, very reliable, cheap in production motor, good for mass production. That's why polyphase system, because it's easy. It's easiest way to get mechanical load driven with cheap and reliable asynchronous motor. Okay. Polyphase network. each phase has an ideal sun-like voltage. And what's it reality? Where is my demo object? Demo. Oh, this one. Oh. Here is my demo object. See, it's a coil with this ring. I have a set of small magnets. I can put these magnets in the ring as I want. These are not usable. I have sets of magnets. Let's look. I free some space. Something happened with my small generator. Here. We will get some voltage. I want to show one idea. And I need a wire for my scope. More wires for the cut of wires. 1 second. We will see voltage, I hope. Where are my... Oh. Like this. Oh, it works. Not a good voltage, but it works. I put one magnet here and another here. Not ideal distribution of magnetic field. You can see this voltage, yeah? I have one and second like this. And we see something like this. What happens if I put another magnet here? For experiment, 1 and distance between magnets. If I put them one near another, I will get with different placement. See what's going on? 2, 1, 2, 1. I can three on the one side and one on another. You see? 3, 1. What my experiment proves? Hey, what my experiment proves? If I have two magnets here, I have 1, 2, 1, 2, and so on. What my experiment proves?
That if we have
Distribution of voltage is determined by structure of magnetic system. If I have, for example, 120 degree with a shift face to face, I will have a voltage system like this. If I, for example, change angles, make it non-symmetric, result, it's a structure of coil. Result will be disturbed, not non-symmetrical voltage system. So angle between phase is determined by placement of coils, of stator coils, not armature. Now you have voltage A phase being sine omega. B phase voltage will be almost 2/3 of T. We have 120 degree shift between phase. And for C phase, for red phase, we will have it's an ideal for first harmonic, or in our case 50 Hertz. In United States it will be 60. Ideal generator. Distribution 120 degrees between phase. But it's ideal generator. And if not ideal, voltage can be written in form of Fourier rho. It will, let's say A phase will be first sine omega plus or max of third sine 3 omega plus fifth sine 5 omega t, and so on. Why I'm missing odd harmonics? Second, fourth, and so on. Because of symmetry. You can check it with simple trigonometry. Because it's not an advertisement of Bosch. If at moment 1 you have this position of rotor, after half of period, it will be opposite. And due to this symmetry, odd harmonics disappear. You need diodes or thyristors or something active to get odd harmonics in the voltage. Check it, it's simple trigonometry. So we have a row like this. For the first harmonic of 50 Hertz, we will have a voltage distribution like this. A, B, C, with angle between them 2/3 of P or equals to 120 degrees. What will we see for the third harmonic? (150 Hertz). So, A phase for the will be some sine 3 omega t. B phase will be sine 3 omega plus 2, minus. What it equals? Third sine 3 omega minus double p. What happens with sine if we shift it back by double p? Can you answer? Huh? What about trigonometry? Nothing. It's a full turn. It equals sine 3 omega. The same thing with the C phase. What will be with the C phase? Same thing, but we will have plus here, so it's equals third sine 3 omega. What do you see? Maybe Facebook can answer. What do you see? For the 50 Hertz, it was like this. For 150 Hertz, we see A, B, C phase equal. And now I will speak for something specific to power engineering. It's called technique of symmetrical components. A method of symmetrical components or Fortescue transformation. Idea of Fortescue transformation is simple. Any non-symmetric polyphase system can be substituted with a set of symmetrical polyphase system. If you have M-phase system, you will need -1 vectorial system with all possible sequences plus 1 zero sequence system representing a ground wire or current in the ground. Fortescue introduced a transformation, a direct sequence, a reverse sequence and zero sequence as 1/3 of 1a square 1a square a 1 multiplied by A phase voltage as a complex, B phase voltage as a complex, and C phase voltage represented as a complex number. A here, A power B equals to minus plus square root of 3 divided by half. It's a rotation operator. Here is for M being 3 for our simple three-phase system. For four-phase. For four-phase system, rotation will be 90 degrees. Here, sitting on the line, this is four-phase motor. Coils, it was, I don't know, it's Bulgarian production from some kind of magnetic store in the middle 70s. I reclaim it from junkyard. Okay, inverse transform. A O B O C is 1 A square A 1 A square 1 multiplied by direct sequence sequence and zero sequence. Its mass general, for simpler. Fortescue idea is to substitute one crippler, non-symmetric system of voltage of current with a sum of ideal A, B, C. Direct sequence system common to market with the 1 plus reverse or negative sequence. It's ideal symmetric but has an opposite phase sequence. It's like ideal generator but rotating in opposite direction. Plus zero sequence system. It's not in Fortescue but Wagner and Evans marked with a 0. Zero sequence system represents a ground or neutral current. In our case, first harmonic or 50 hertz acts as a direct sequence, ideal symmetrical polyphase system. Here we will have 150 hertz or third harmonic. All voltages and all currents in all phases are equal. Sounds like nightmare, isn't? Yes, it's electrotechnics. Electrotechnics books are usually that size. And theory of signals books are usually What about, I have a gap here, something missing. It will be 250 hertz. Fifth harmonic. What?
Is there a reason for harmonic?
In ordinary network, they go down and with an amplitude. In ordinary network, highest is a third, then fifth, and goes down. But ordinary network means no power converters. With the power converters, situation is first decaying normal, or let's say old style harmonics, and then can be peaks from converters. For example, often you can see peak at somewhere around 8 or 10 kilohertz. On frequency on converters and higher harmonics, possible odd, from the converter internal frequency. Most painful it's for high energy metal processing plant when electrical furnaces are installed. Very typical things, fifth, seventh goes down and up at 40. Such business I usually get high problem with regulators and need active filters to suppress it. This one, okay, we have radio interferences, we have blah blah blah, but key problem, on a high frequency, insulation decays rapidly. It's a real pain for metal processing. Cable infrastructure, it simply burns out. What I was thinking about, I would like to show another small experiment. So, idea why such distribution of vectors is clear. This proves? I hope so. Way to insult Greta Thunberg. Three-phase wall. I got a three-phase wall. So this will be my be my phase A. This can be phase B. Can I find a wire form? 1 second, I will assemble. Very simple then. I have a star transformer. This is ground. I will install current sensor here. 1, 2, 3. This goes up. Here will be this 1/10 of the ohm resistor. I will take this signal and this signal. Possible. More wires for the cut off. This is my B phase. This will be my phase C. I will need a neutral. This is okay, but where's the school? Where are you? Oh, yeah. Got it. This will be okay. This is my ground. Let's see what happens. Yellow one is an A phase current, and what about blue one? Oh, let's see. This is good. Do you see? Current of A phase and current of ground. Why it's 0? Can you answer? Why blue line is 0? Yeah. It's so simple. This is A phase voltage represented as a vector. Current will be the same. Sum. What is the neutral current? Sum of A plus B plus C. This is A plus B plus C. Results equals to 0. What will happen if I disconnect one of the wires? If I disconnect B phase, can you answer?
B phase.
Yeah. I see my discipline is not interesting you.
120 degrees.
I will disconnect this.
240 degrees.
If this is 1 and this is 1, think what will happen. This is A. I should add C. This is plus C. And this A plus C will be, wait 1 second, this way. The sum of the, or minus B phase. Take a look. This one should be, was 200 millivolts. All phases are connected, B phase is disconnected, and current equals to minus B. It's another big plus of polyphase network, exactly, three-phase network. In the symmetrical regime, when all phases are loaded equally, current in the ground wire will be 0. That's what theory says. Nice theory, isn't it? I can discontinue C phase, current will be equal to C phase. I can disconnect A phase, current equals to phase. So current in ground wire never exceeds phase current. Nice. Nice? Nice. What kind of lamps I have? Incandescent. Active load. Too simple, isn't it? It was yesterday. Yesterday is not today. Let's take hot out ordinary incandescent lamps and put modern LED. I hope nothing bad happens. Where's my B phase? Hey, come on. What's wrong with you? Where's my B voltage? Oh, here is my B voltage. So, welcome to our life. You. Here is current of A phase. That's what LED lamp is consuming. Why? Because it has a DC stage on the input. And the blue line is a neutral current. What the frequency of it? Can you answer? What's the main frequency of the blue signal? Triple. Blue line contains one second, we will see its spectral composition. First peak, 150 hertz. Second one, 450. Next one, 745, and so on. We have a set of free n, where n is an integer, harmonics. Sum of the first harmonic. We have in the ground, we have vectorial sum of current. Sum of the first harmonic is 0. If all bulbs are equal, sum of the first harmonic will be 0. Sum of the fifth harmonic in the ground wire will be 0. Sum of the third harmonic will be triple. So in modern life, you'll see not a zero current in a neutral, but triple current of harmonics with number 3, and when n is an integer. Do you understand it? I'm not sure. I think I need a demo with rectifier. All modern electronic loads have a rectifier at the input. There always will be a DC stage. Typical structure. Bridge, AC input, capacitor filter, switch controlled by PWM, for example, transformer, should be a number network, ground, feedback to PWM, controlled by PWM. They all modern loads have a DC stage at the input. This box has a DC stage at input. One moment, I will my rectifier demo. More demos for the god of demos. Have free space for myself. Network. More networks for the god of networks. Right here. Rectifier. What the hell's? This not needed. R means rectifier. This is my rectifier. For simplicity, I will I will do network like this. Rectifier. Here will be current source, current sensor. Active load. This will be voltage and filter capacitor separately. 1 second. What's this? This is ground. Ground should go here. Let's see. This is current from current, and if this is current, oh no, it's okay. This is current. This is current. This is current. Okay, I will do like this. This goes here. And this goes here, and possible wires against me. I need a schematics assembling guide. see what happens. It's blow or glow. Something wrong here. Oh, of course it's wrong. Yeah, this goes here. Something like this 100 volts. Yeah, I got my network. Blue line is a current. Yellow line, load voltage. Effective 101, voltmeter shows 100. Something familiar? Okay, who studied power electronics? Is the picture you think okay? Current from the primary side is a sine. Yeah? And voltage on the load is an absolute value of sine. Yeah? Nice? What your Facebook says, it's okay with power electronics? No? No problems. Red line is a spectrum composition of current. This is okay? You do understand what happens? Who has studied power electronics? Who knows how bridge rectifier works? Do you know how bridge rectifier works? No, I'm asking one particular person. Yes, you.
The bridge like this?
Yeah, bridge like this for diodes.
Yes, of course. Like, if the current is positive, it gets to the same point, and if it's negative, it also gets to the same point.
Yeah.
Because of the disposition of the diodes.
Yeah. In one current, first and third diodes works on the positive waves, on negative waves, second and fourth will work. This corresponds, this voltage, to this theory. Nice. What should I add? At this moment, the switch is open. We don't have any filter here. This is what everyone heard. Yeah? And what happens when I add a filter? I will add this capacitor. What will happen? Plus 20 microfarads. voltage is closer to DC. See the difference? Without filter, with filter capacitor. Capacitor charges at the peaks and discharges. But look what happened with the primary current. You see? Case ideal situation. With the 20 microfarads, with 40, this is closer to DC. Do you see what happens? Uh, 80 microfarads. Output voltage near to DC. But you see why these peaks are happening. You have a charged capacitor and bridge diode. Voltage goes up, 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 but diode is closer because capacitor is charged, and on this side voltage is high until at the peak of sine. See what happens? It's like very simple model. Going up voltage of network. You have like capacitor with and some load. It's not important. Before voltage reaches capacitor, net voltage reaches capacitor voltage, current do not flow. At the moment when voltage is high, when capacitor, you have a current surge. See this peak? Without filter, we had nice aesthetic sign. Add a filter and you have a set of pulse. This. With inadequate filter, too small or capacitor dried out. You see what happens? Multiple peaks because voltage is not ideal clean. With when the filter is 200 microfarads now, you will see system of high peaks. Watch on spectral composition. Where is my cursor? Look. Oops. It was. Come on. 50 hertz. Next one. 150. Next one. 250. 350 and so on. By the way, effect of the filter. Without filter, effective 50 Hz. With 140. See? Field rise efficiency of rectifier. But this is current you see in net. This is more than load. That's what you saw as a current of my bulb. In neutral, some of this will be 0, this will be triple, some of this will be 0, and phase 9 again will be triple. No modern day networks are very different from the old time theory, because modern loads all have rectifier part at the input, all frequency inverters, all lighting, they all have electron ballast model. And more you will see current like this. And for such kind of current, very important to understand what each harmonic, it should be decomposed into Fourier row, and for each harmonic, we will see its own circulation path. Because first harmonic, 50 Hz, rotates as usual. Third harmonic forms a zero sequence. It will be triple in ground wire. Fifth harmonic forms a negative sequence. That means what magnetic field of the fifth harmonic goes in opposite direction. While third harmonic spins, let's say, forward, fifth harmonic spins backwards. It tries to slow down your machine. When you have a network with high, let's say, output resistance, low power network, when traditional large generators are connected to the network, third harmonic circulates in the neutral of transformers. Fifth harmonic is closed by windings of hydro generators. If you have, for example, an ice with only solar and wind power, you will have no path for fifth harmonic to close in generator. Because inverters of photovoltaics and inverters of wind generators do not pass fifth harmonic through them. And you will see corrupted voltage. In worst case, you will have to pay for active filter to suppress fifth harmonic, plus set of capacitors. This will slow down your machine. This will make you pay. Yeah. So, I showed them in opposite direction, but you saw both. Neutral wire of modern networks is a path for the third and so on harmonics to circulate. If you want to hire electrician, you know, a good test for electrician. I want to hire electrician. What should I do? What's this? Current clamps or Dietz clamps. Inverter's name was Dietz. Dietz clamps. What it's for? To measure current. You can take any wire, cats, or 2 amps. Good. If you want to high electrical, take a current clamps and go to the place where cable goes into your building. Measure A phase, for example, 25 amps. B phase 24, C phase 26. And then ask, what will be measurements at neutral? If I have 25, 25, 25, let's say round number, what will be neutral current? What? 25 at green, 25 at yellow, 25 at red. What will be at ground? Huh?
Ground?
Yeah, at ground wire, at neutral, at blue wire. some countries paint black. Black and white, or pure black, or some paint white. So, at neutral wire, what will be? If I have, let's say, around 25, 25, 25.
Minus
25 plus 25 plus 25 equals to 0. Nobody gave me before torture 0. Okay, idiot's answers 75. Take a shower, go to bed. Bit prepared guy answers 0. Okay, we can hire him. And when you measure, will you get 0?
I guess there will be some losses.
No, not losses. 25 years ago should be 0. Now, never. You have building full of PCs, lightings and so on. You will see 5, 7, something like this. And if ask why. If guy answers it's a third harmonic, grab him. Grab him. If answers shower. Okay, I think it's not so easy, but to understand it you need, what you need? Simple vectorial operation. It's a very simple. Assume voltage or current like this as a shadow or projection of rotating vector. If rotor stands like here, this vector goes up. It now stands this way, vector time goes up. Okay, I think it's enough for today. Some questions maybe? Last time to ask a question.
I have a question about
I don't think it was recording. Yeah.